Okay, now we are going to start with the first chapter of chemistry. We'll be referring to Virav Dalal textbook for the this particular chapter, that is modern periodic table. Now in the ninth standard we had learned that the periodic table had evolved, or basically it was formed by in stages. Like first thing was the Daubigne's triads, which failed. Then there was the Moseley's the Newland's octave, which also failed because at higher number of values of the atomic masses it did not work. And then came the Mendeleev's periodic table, which was in a form of a table. It was quite proper, and it was, only thing is that it was based on the atomic masses. It had got spaces also available. It was divided into rows and columns. So that was, the rows were called as the periods and the columns were called as the groups. And then it was then modified by Moseley, and Moseley gave us the modern periodic table, which was the modern periodic table, which is based on the atomic number. So as soon as everything just changed, all the different parameters through which the things were failing were automatically changed when the periodicity was converted from, or you can say the periodicity was changed from being the atomic mass to atomic number. So once that was done, so arranging the elements of the known elements in the increasing order of their atomic numbers was a main principle of the, or you can say periodicity of the modern periodic table. So we see that the modified Mendeleev's periodic table and stated that the basis of the classification of the elements be according to the increasing atomic numbers and not atomic weights, since physical and chemical properties of elements depend on the number of electrons and their arrangement. So this was the basics on which the change of the periodicity was taken care. Another important thing what we need to remember is what is an atomic number. The atomic number is equal to the number of electrons or the number of protons present in the atom. That is, the number of electrons will be in the energy shells. So when you see the energy shells, it is as per the electronic configuration. So that's why, because of the electronic configuration, because of the valency, they are placed in the different forms, and we have got different fundamental properties of the elements based on that. So the modern periodic law states that arrangement of the elements in the periodic table is thus based on the modern periodic law, which states that physical and chemical properties of elements are periodic functions of their atomic numbers. So physical and chemical properties are based on the physical and chemical properties of elements are periodic functions of their atomic number. Now the salient features will be that, first of all, classification based on atomic number. Second is the position will be based on electronic configuration, and the method of arrangement is there are 7 periods, which are the rows, and there are 18 columns. So 18 columns and 17 periods. The 18 columns, in the 18 columns we have got the first column over here. The first group is called as the alkali metals. The alkali metals, or the first group, and the second one is alkali earth metals. The 17th one is the halogens, and the 18th one is inert gases or noble gases. So that's the basic ones which are there. So accordingly we see that the groups are from 1 to 1, 2, and then 13 to 17 are also called as the 1A and to 7A are the normal elements. Normal elements are those elements which are going to follow the octet and the duplet rule properly. So that are called as the representative elements or the normal elements. Whereas between 3 and 12, they are the one which are going to be called as the transitional elements. So 3 to 12 are the transition elements, and the 18th group is the one which is the noble gases over here. So we see that if I consider that this is your periodic table, Then this periodic table has got 7 periods over here. So it is 1, 2, 3, 4, 5, 6, 7. And over here it is 1, 2, 3, 4, 5, 6, 7, 8. And then it's 13, 14, 15, 16, 17, 18. So this way it is going to go like this. So 1, 2 and 13 to 17, these ones are called as the representative elements or normal elements. So these are the normal elements. This one over here is the inert one, and the between ones, that is 3 to 12, are called as the transitional elements. This is transitional. Okay, so that is transitional elements. Now, it is normally seen that the one to the extreme left hand side are the metals. So we can consider that these ones over here will be metals, whereas these ones over here will be non-metals. So of course 17 over here will be non-metals. So normally it will be that 1, 2, 3 will be metals. As such, we know why it will be, because here the valency will be 1, your valency will be 2, your valency will be 3. We know that if valency is 1, 2 or 3, it will be a metal because they will be giving away their electron. Whereas if it is over here 13, 14, 15, 16, so not 13 but 14, 15, 16, 17. So it will 15, 16, 17, you know that the valency will be -1, -2, -3. Accordingly, they will be non-metals because they will be accepting the electrons. So this is how they are going to be gradually be going towards non-metal side, from metallic to non-metallic. So this is highly metallic, this is highly non-metallic. Now in case of the period, so this was the group about the periods. You can see that the period is this way, that this will have only one shell. So it is K shell, this is K and L, that is 2 shells, this is K, L, M, this is K, L, M, N. So you can consider that the period number also indicates the number of shells present in that particular atom. Group number will tell you the valency, that is the valence number of electrons, and the period number, that is the period number will give you the number of shells or the number of orbits which that particular atom is having. So that gives you the difference between the periods and groups. Now let's go a bit in detail about the modern periodic table. So you can see, talking about the period, first thing is that first period is a very short period. What short period? Because it has got only 2 elements, one over here and one over here, that is hydrogen and helium. So that is having only 2 elements. That's why it is called as the shortest element. The next one, that is 2, has got 8 elements. So that will start with lithium and end with neon. So atomic number 3 to atomic number 10, which is also a short period, which is only 8 elements in that particular period. The period number 3 has also got only 8 elements, that is from 11 to 18, that is sodium to argon. Then the fourth one is a long period of 18. So it is only from this particular fourth period that all the 18 of them are filled up. Till that time, this part, that is the transitional part, is not going to be filled up till the third period. Till the third period, you can see that the third period, this part will be empty. Okay, it will be only this way. So here it is only 1 and 2. So this will be hydrogen and helium over here. Over here, it will start with lithium and so on, and then this is empty and it continues over here. So the second period 8, third period 8, fourth period will be 18. Now fifth period again is 18. Sixth period is going to have 32. Now this is because there is the inner transition elements present in the 6th and the 7th over here, which are called as inner transition elements, which are given as a separate table at the bottom over here. That is the lanthanides and the actinides. So this are the two which are going to be added up to over here. So this part over here is going to be represented by here, and this part over here will be represented here, and accordingly this will be added to this. Hence they are called as the longest period, including the lanthanide series and the actinide series, which are making it 32 elements in that particular period. Their periods also have certain interrelationship between them. That means the period 1 will have a cross relationship, यानी इसका इसके साथ में relationship है. That is called as a bridge element. So bridge element are the one in which the first group has, see, normally all the groups have same properties. One group has the same properties, but here group 1 has similar properties to group 2, but in the next period. So that's why it is called as the bridge element, because it is bridging the two groups. So what is the similarity in the period is that within the same period the number of electron shells are the same. So if you talk about one particular period, then this will have only 2 shells, this will have only 3 shells, this will have only 4 shells, this will be 5 shells. So the similarity in all the elements present in a particular period is that the number of electron shells are the same. The next is the transition of the electrons, that is, it is going to be increasing by 1. As I go from left to right, my number of atoms will keep on increasing from metallic to non-metallic side. So valency wise increase by 1, and non-metallic characteristics, it is going to keep on transiting from metal to non-metal. So within a period, the 3 things are: first one, similarity wise, all in the group will have the same number of electron shells. Second thing is, when I go from left to right, it is going to be seen that my valence is going to be valence electrons, which is going to increase by 1. And thirdly is that this, when I go from left to right, the metallic characteristic keeps on decreasing and non-metallic characteristic keeps on increasing. So this is highly metallic and this is highly non-metallic. So metallic to non-metallic characteristics is going to take place. So in this way you can see that there will be the periods of period 1, 2 elements, period 2, 8 elements, period 3, again 8 elements. We can easily understand if we know the atomic number, we can find out the electronic configuration, and according to electronic configuration, if the electronic configuration may last valence electron is 1, 2 or 3, it will be metallic. If it is 4, it could be metal, non-metal or a metalloid, and the next one could be non-metals. And so valency will be 1, 2, 3, 4 and 3, 2, 1 and 0. So accordingly you will be having all these characteristics. Similarly, they will always, all these compounds, they will be always be able to bond with chlorides, that is halogens, and when they will do so, because chlorides are non-metals, so when they are going to react with the metals, they are going to form an ionic bond. We learned that in chemical bonding, and here it will be a covalent bond. So same way we are going to have different kind of oxides, hydroxides and hydrates, which are going to be formed, but not so important to learn. The next thing is about the groups. So as per the groups what we are talking about, we just said that one group, this group 1 is the, or we can just write down once again. So you see over here that the first group over here is alkali metals. So if it is the first one, it is alkali metals. The second one is alkali earth metals. Okay, the first 2 are alkali metals and alkali earth metals. 3 to 12 are transition. Now 13 to 17, so 17th is the halogen and 18 is inert. Now 13 to 17 over here are again normal dependent elements, and so that is post transition. Also you can say 13 to 16 can be considered to be as post transition. So 13 to 16 is post transition, and 17 is halogens, and 18 is noble gases. We can always differentiate between, so similarity wise we can say the similarity between the same group. So we have over here that the valence electrons in one group will always be the same. So all these alkali metals or whatever there, they all will be having. So if I have over here as hydrogen, lithium, sodium, potassium, and then rubidium and cesium and francium. Now francium being this one is in radioactive, so normally it is not considered. But anyway, when you are going through this, all these will have the valency as 1. Okay, the outermost orbit will have only 1 electron, so that's why the valency over here is going to be 1. Similarly, if it is 2, then it will be having 2, this will be having 3, and this will be 4, 5. In this way it is going to keep on increasing. So accordingly we will be having the similarity as valence electrons remain the same. Second, chemical properties. Now because the valency is the same, so chemical properties are also going to remain the same. So they will be very much identical to each other. The chemical properties like sodium and potassium, they are like brothers, they are very, very common. They are very interchangeable. So that's why they will have a similar kind of properties, but as you go down, we are talking about the properties later on in the chapter. So we can easily identify, or you can easily differentiate between the group 1 and group 17 over here. The group 1, that is alkali metals, and group 17. So first of all, both are univalent. Only difference is this is +1, this is -1, but you can call them as univalent. Nature wise, both are highly reactive, but only thing is this is electropositive in nature, this is electronegative in nature. And this will be light soft metals, where this will be non-metals. These metals are such that they are so soft that they can even be cut by a knife, whereas these will be normally gases. So that's the difference between the two. Of course, fluorine and chlorine are gases, whereas bromine is a liquid and iodine is so. Now this is something important. So we have over here lithium के सामने यहाँ पे अगर आएंगे तो fluorine, chlorine, bromine, iodine. Now these two are gas, this is liquid, and this is solid. So that's the main part over here, that it's very important that at room temperature a solid non-metal will be iodine. So that's an important question. Conductor wise, conducting electricity or heat, these will be good conductors, this will be bad conductors. Reducing agents wise, this will be strong reducing agents, this will be strong oxidizing agents, because this is going to give away the electrons, so they get oxidized, they are going to get reduced. So here, one electron over here it is going to lose, so it is going to get oxidized, so that's why they are going to be strong reducing agents. What are reducing agents? The one which oxidizes. That means they are going to get oxidized. How they get oxidized? By giving away electrons. So this give away electron, hence they get oxidized, hence they are going to reduce something. Okay, similarly over here they are going to gain electron. Gain electron is reduction, so they are good oxidizing agent. Right. So strong reducing agent, strong oxidizing agent. Electronegative, so low electronegativity, whereas high electronegativity. And electrovalent compound wise, with the reaction with non-metals, these are going to make electrovalent compounds, ionic compounds, whereas this is going to make as covalent compounds. So that was about the groups and different periods. Now we go to the periodic properties, what are there, and we'll also find out what is the reason for this particular properties of this particular. Now we are going to learn 5 different properties, and these are very, very, very important properties of the we can say periodic table. So periodic trends, you can call it as the periodic trends of the periodic table. So we are going to learn 5 things. One is the atomic size or also the radius. Then we are going to learn ionization potential, then electron affinity, then it is electronegativity, and finally is metallic non-metallic. So these are the, we consider two separate ones, metallic, non-metallic. So these are the 6 different properties what we are going to learn, and these are very, very important part of the chapter. Whatever we did earlier was just a recap of something of the 9th standard and something, but not so important. Normally not too much of a questions are asked about those things, but these are the main ones. Okay, so let's start with one by one the explanation and understanding each and every periodic property and the trends with which the property is going to change in a periodic table.